Welcome back. Let's do question 3.3. In the diagram below, PQRS is a parallelogram having diagonals PR and QS intersecting in M. B is a point on PQ such that SBA and RQA are straight lines and SB is equal to PA. SA casts PR and C and PA is drawn. Prove that AR is equal to 4MB. We want to prove that this AR is equal to 4 times MB. So we have to construct MB here. PQRS is a parallelogram, meaning that M is the midpoint of PR. It is also the midpoint of SQ because the diagonals bisect each other. The diagonals of a parallelogram bisect each other. And then we have this parallelogram. Also, we prove that this is a parallelogram, meaning that B is the midpoint of PQ. It is also the midpoint of SA because the diagonals of a parallelogram bisect each other. Well, let's write that. M is midpoint of PR, diagonals bisect of parallelogram. And then B, the midpoint of PQ. B is the midpoint of PQ. Again, diags bisect of parallelogram. We can construct our MB. Let's look at this triangle. In triangle PQR, what can you say about MB and QR? Right, you can see that MB is equal to half of QR. Then what is the reason? That's the midpoint theorem. Okay, B is the midpoint, M is the midpoint. So a line segment drawn from the midpoints of two sides of a triangle is parallel to the third side and equal to half the size of the third side. So it means MB is equal to half of QR. Then there is a midpoint theorem. QR is equal to AQ. We prove that using the converse of the midpoint theorem. QR is equal to AQ. So meaning that QR is half of AR. QR is half of AR. So you can say, but QR is equal to half of AR. So meaning that where there's QR, we can write what? We can write half of AR. So we can say here using this one, MB is equal to half of QR, and then QR is half of AR, and then half of AR, and then now half times half is 1 over 4. So MB is equal to 1 over 4 times AR, and then we multiply both sides by 4. So 4MB is equal to AR. Okay, which is this, right? AR is equal to 4MB.